Hello, and welcome to Boot Camp, Unit 8C, Scientific Notation and Negative Exponents. We're going to be using these to measure things that are either really big or really small. You don't want to measure just the number from the how far the sun is from Earth. That number is so big that I believe there are 6 zeros in that number. It gets really big really fast. Likewise, you don't want to measure the weight of a hair. That was so small that we need a better way to kind of organize our thoughts, which is where scientific notation comes into play. What you'll see here is the breakdown of a scientific notation written number. It is something like the form of 3 times 10 squared. The big key here is that the number out front is between 1 and 10. And the power is what's going to dictate whether it's really big or really small. If it's bigger than, if it's positive, then we will have a bigger number. For example, if we have 3 times 10 squared, that is 10 squared is 100, and 3 times 100 is 300. A way to quickly do that is to take your 3 and move your decimal point 2 to the right. In doing so, you get back to 300, filling in circles or filling in zeros along the way. When we look at 3 times 10 to the negative 2, what does that really mean? That is going to be a really small number. I'm going to take my 3 and move it 2 decimal places to the left, 0.03, filling in zeros along the way. Now, we use smaller examples to help get the concept across, but you can imagine when we have numbers like 3 times 10 to the 27, that is a 3 followed by 27 zeros. Likewise, 3 to the negative 27 is 0.26 zeros and then 3. This is where scientific notation really has its use. Like we had said, the distance from here to the sun, or maybe the weight of a hair. Things that are either massive or the exact opposite. So what are these negative exponents? We're mentioning 3 to the minus 2. And so when we say that, well, the word for it often is flip, with a little bit of a caveat on that. If we say x to the minus n, that is in the top. If I call that a fraction, x to the minus n over 1, it's going to cross over into the bottom. Whatever you have, it's going to cross to the other side of the fraction. What you'll see here on the right is when we have 5 to the negative 1, that's in the top. So it's going to end up in the bottom, 1 over 5 to the positive 1. In this case, notice how I'm writing the 1 there because the exponent is going to stay the same number, but just change its sign. For example, if we had 5 to the negative 2, instead of being 1 over 5 to the positive 1, it'll now be 1 over 5 to the positive 2. 5 squared is 25, or 1/25. In the same vein, if we have a negative exponent in the bottom of a fraction, it'll move up to the top. 1 over 5 to the negative 1 is just the same thing as 5 to the positive 1, or just 5. That is Unit 8C, Scientific Notation and Negative Exponents.